It's a strange thing to live in an age where human beings can edit the code of life, yet still struggle to edit the code of their own minds. Where we can reach back billions of years through telescopes, but can't reach across a dinner table without arguing about the truth. We can transmit thoughts instantly across oceans, yet can't seem to transmit empathy across a city block. That, right there, is the paradox of progress. We've built machines that think faster than we do, algorithms that predict what we want before we know it ourselves yet. The average person feels more uncertain about the future than ever before. The more we seem to master time, the more we feel enslaved by it. Minutes vanish into screens, days blur into deadlines, entire years dissolve into the background noise of productivity. And so the question arises, if humanity has advanced so far, why do so many of us feel like we're falling behind? It's as though we've become travelers moving faster and faster through space, yet no one's entirely sure where we're going. When we look back through history, progress has always come with paradox. When humans first harnessed fire, we illuminated the night and also learned how easily the light could burn. When we split the atom, we unlocked the energy that fuels the stars and the power to erase entire cities. Every leap forward has cast a shadow behind it. And today, in the 21st century, that shadow is longer than ever. We've learned to manipulate time on a technological scale, from atomic clocks that measure the universe's heartbeat to quantum computers that operate in superpositions of the past and future, and yet we hardly understand the very phenomenon we live within every second of our lives. What is time? A river? A dimension? A trick of perception? Or something far deeper, a structure in which consciousness itself participates? We live our lives as though time flows, one moment after the next, a steady stream from was to is to will be. But physics has whispered something far more unsettling. Time may not flow at all. It may already be all of it laid out, like a landscape, a cosmic terrain where past, present, and future coexist, each waiting for consciousness to wander through it. Einstein once wrote that for us. The distinction between past, present, and future is only a stubbornly persistent illusion. He didn't mean that time isn't real, only that our experience of it might be. We perceive it as a sequence because our minds evolved to survive in a sequence. But in the equations that govern the universe, there is no arrow, no privileged direction, no forward, no backward, just relationships, correlations, and symmetries that remain indifferent to the ticking of our clocks. And yet, here we are, counting seconds. Our lives ruled by devices that tell us the time, as though this invisible quantity were something that could be stored in our pockets. Think about that for a moment. You're holding in your hand right now, perhaps a phone that synchronizes with satellites orbiting tens of thousands of kilometers above Earth, each carrying atomic clocks so precise they lose less than a billionth of a second per day. Those satellites communicate with your device to tell you where you are on the planet, using nothing but the difference in time. Every map, every GPS coordinate, every direction we follow is literally built from time itself. Time has become our compass. And yet, we don't know what it is we're navigating through. In the quiet corridors of modern physics, a strange idea has emerged. Time might not just be something we move through. It might be something we create. Each measurement, each observation, each conscious moment, shaping what we call the present. Could it be that the future isn't waiting for us to arrive, but instead is waiting for us to define it? That question isn't philosophy. It's quantum mechanics. At the smallest scales of existence, reality behaves like a series of possibilities rather than certainties until it is observed, until it interacts, until something or someone chooses a path. That's the quantum paradox. The universe doesn't seem to commit to an outcome until it's forced to. And when it does, it leaves behind the unmistakable signature of choice. So perhaps the paradox of progress isn't that we don't understand the future. It's that we don't yet understand how deeply we participate in it. Every atom in your body was once part of a star. Every breath you take has been recycled through oceans, forests, and countless generations of living beings. You are quite literally the universe aware of itself, condensed into the fleeting moment we call now. And if time, as Einstein hinted, is just another dimension, then your now is not a fixed point, but a moving intersection through the fabric of space-time. You are the traveler. Your awareness is the vehicle, and the destination? That depends on how you steer your perception through the possibilities that quantum reality provides. So, as we stand here at the edge of artificial intelligence, genetic engineering, and quantum computing, we must ask, are we accelerating toward understanding time, or merely building faster clocks to count our confusion? Could it be that time travel is not a dream of science fiction, but a phenomenon already whispering to us from the quantum realm happening all around us, and even within us every time we make a choice, remember a past or imagine a future? Perhaps the true frontier is not to build a machine that moves through time, but to understand that we already are one. If you could step outside of time, not just imagine it, but truly step outside, you would see your entire life at once. Every breath you've taken, every decision you'll ever make, each folded neatly beside the other like pages of a book. A book that doesn't begin or end, but simply is. From that perspective, the question, what time is it, wouldn't make sense because the whole story already exists. But we can't see the book. We can only read one word at a time. That's the illusion of time. Not that it doesn't exist, but that we can only experience it sequentially. Our ancestors didn't have atomic clocks or GPS satellites. Their measure of time came from the sky, from the rhythm of the sun and the stars. The Earth's rotation gave us day and night. Its revolution gave us seasons. The moon marked the months. Time was not something to manage, it was something to live within. When the first farmers sowed seeds, they didn't count hours, they counted dawns. When early astronomers built stone circles in observatories, they weren't tracking seconds, they were tracking cycles. To them, time was circular, eternal, like the wheel of the heavens turning endlessly above them. It wasn't until the rise of civilization and the need to synchronize human activity that time became something to be controlled. In the 14th century, a new sound began echoing through Europe, the ringing of mechanical clocks. Each tick marked progress. Each tock, accountability. For the first time, time was divided not by nature, but by gears. Humanity had taken something fluid, something cosmic, and trapped it behind glass. From that moment forward, time became currency, something that could be spent, wasted, or lost. Centuries later, the Industrial Revolution sealed the deal. Factories demanded schedules, railways demanded timetables, and human beings became servants to the clock they had built. Our language even changed. We began to save time, kill time, run out of time. As if time were a resource and not the very fabric of existence itself. And then came Newton. To Sir Isaac Newton, time was absolute, a grand stage on which the events of the universe unfolded. He imagined it as an invisible, universal river, flowing at the same rate for everyone, everywhere. A second on Earth was a second on Mars. A second in your living room was a second in the heart of a distant star. It was a comforting idea, the notion that time was fixed, predictable, unchanging, a universe built like clockwork. And for 2 centuries, that model reigned supreme. But nature, as it always does, had a twist in store. When Einstein appeared on the scientific stage, he didn't just challenge Newton's mechanics, he challenged our very sense of reality. In 1905, a young patent clerk dared to suggest that time was not absolute, that it bends, that it stretches, that it flows differently for each observer depending on their motion through space. It was the birth of relativity and the death of absolute time. Imagine 2 twins. One stays on Earth, the other travels to a distant star at near the speed of light, and then returns. When they reunite, the traveling twin is younger, not in perception, not in memory, but in reality. The faster you move, the slower time flows for you. That's not science fiction, that's physics. Einstein had shown that space and time are not separate entities. They are woven together into a single cosmic fabric, space-time. And in that fabric, mass and energy curve reality itself. Gravity is not a force pulling us down, it's the curvature of space-time, telling matter how to move. Time doesn't simply pass, it flows along these curves, bending and stretching with the shape of the universe. So what happens when you approach something massive enough to warp space-time completely, say, a black hole? Time slows. Closer and closer you fall, until the seconds stretch into hours, hours into years. To an outside observer, you appear frozen at the edge of the event horizon, trapped in a moment that never ends. But from your perspective, you would continue falling, in time for you would feel perfectly normal. Two realities, both true, both real, yet completely different. That's relativity. That's the illusion shattered. Time, it seems, doesn't move at all. We do through it. At different rates, along different paths, depending on how we move and what we're near. Einstein once wrote that when a friend dies, for us physicists, the distinction between past, present, and future is only an illusion. He meant that in space-time, all events exist, always have, always will. Births, deaths, wars, revolutions, they're all points in a vast cosmic map. And consciousness is simply traveling through that landscape, moment by moment, frame by frame. We call it the passage of time. But maybe it's just our passage through time. And that realization raises a haunting question. If every moment already exists, does that mean the future is already written? If we could somehow step outside of time, would we see all outcomes, all choices spread before us like branches of a cosmic tree? And if so, what does that say about free will? Philosophers have wrestled with this for centuries. But the deeper we dive into physics, the stranger it becomes. Because even Einstein's space-time elegant, geometric, deterministic began to crack under the pressure of the quantum world. Beneath relativity's smooth fabric lies a reality that is anything but smooth, a seething quantum foam, where particles pop in and out of existence, where uncertainty reigns, where cause and effect blur at the edges. Here, the illusion of time fractures completely. Events don't just happen in sequence. They can happen in superposition. Particles can be in two states, two places, even two times simultaneously. And that brings us to the threshold of something extraordinary. If the quantum realm doesn't obey the arrow of time, then perhaps the future can influence the past, not metaphorically, but physically. Could it be that time travel is not a fantasy, but a natural feature of the universe we've simply not learned to perceive? That every moment, every choice sends ripples not only forward but backward through the quantum sea? It's here in the microcosmic chaos beneath our reality, where the illusion of time dissolves entirely, and where we begin to glimpse something astonishing, that causality itself may not be as linear as we think. In that realm, the boundary between before and after is not law, it's preference. And the universe, it doesn't seem to care. So as we stand here, looking at our watches, measuring our minutes, racing against deadlines, perhaps we've misunderstood the game entirely. Maybe time isn't something we spend, maybe it's something we inhabit. Maybe every second of our lives, past, present, and future, still exists, waiting for our consciousness to arrive. And maybe, just maybe, we're already moving through time in ways our senses cannot yet perceive. When you shrink your perspective small enough, smaller than atoms, smaller than the very structure of light, the rules of the universe begin to change. Cause and effect start to blur. Here, in the quantum realm, the universe behaves like a dream told by two narrators at once, one speaking forward in time, the other backward. It is a realm not of things, but of probability, a world where particles do not exist in a definite state until we look at them. Until that moment, they're waves of potential smearing across time and space, like whispers of possibilities that haven't yet decided to be. And this isn't just theory, it's experiment. When physicists first explored this subatomic landscape in the early 20th century, they expected to find tiny billiard balls, predictable, tangible, Newton's laws written in miniature. Instead, they found something else entirely. They discovered that an electron, when unobserved, behaves like a wave, a shimmering cloud of probability. But the instant we measure it, it collapses into a particle. It chooses, and in that choice, reality becomes specific. That simple act observation shattered everything we thought we knew about objectivity. Because what does it mean when the universe waits for you to look at it before it decides what it is? The famous double-slit experiment became the crucible of this mystery. Fire electrons at a barrier with two slits, and if no one looks, they behave like waves interfering with themselves, creating patterns of light and dark. But if you place a detector to see which slit each electron passes through, the pattern disappears. The electrons act like particles instead, as if the mere act of observation changes what is real. Einstein hated this. He once said, "I like to think the moon is there, even if I'm not looking at it." But quantum mechanics replied, "Are you sure?" Now, here's where it gets truly strange. Decades after Einstein, experiments began to show that these effects aren't limited to space, they extend to time. In a series of what are called delayed choice experiments, physicists sent particles through slits, but made the decision of whether or not to observe them after they had already passed through. And somehow the results still depended on that later decision. It was as if the particles knew what the experimenter would do in the future and adjusted their past behavior accordingly. Let that sink in for a moment. The future seemed to be reaching back and rewriting the past. Not metaphorically, literally, in the data. This is what physicists began calling retrocausality, the idea that effects can precede causes, that information can travel backward through time. Not on the human scale of seconds or years, but at the quantum scale, the most fundamental level of reality. If that's true, then time as we know it is not a one-way street. It's a two-lane highway. Information might move forward and backward, looping between possibilities until observation, that moment of conscious interaction, collapses it into one consistent timeline. And if time can bend in both directions at that scale, could time travel already be happening there silently in the fabric of the universe? Let's pause and think about this. In the world of atoms and particles, the universe doesn't distinguish between past and future. The fundamental equations of physics, from Newton to Schrödinger, are time symmetric. They work perfectly well whether time moves forward or backward. The only reason we experience time flowing forward is because of something called entropy, the tendency for things to move from order to disorder. Ice melts, smoke disperses, stars burn out. Entropy increases. That increase gives time its arrow a direction we can point to and say, that's the future. But entropy is statistical. It's not a fundamental law. It describes averages, not absolutes. And at the quantum level, where individual particles play by different rules, that arrow begins to flicker. Sometimes it even reverses. Imagine reality as a great film reel. In the macroscopic world, we watch it frame by frame, always forward. But at the quantum level, the reel is unspooling both ways at once. The story still being edited, the final cut not yet made. The universe isn't a movie that's already finished, it's a film in progress, being co-directed by the laws of physics and the act of observation. And this leads to a stunning possibility. Maybe the present moment isn't just shaped by the past. Maybe it's co-authored by the future. If that sounds impossible, remember that information is the most fundamental currency of reality. Quantum particles are information carriers. They don't just exist, they encode. And information, unlike matter or energy, doesn't always obey the same boundaries of time. Consider quantum entanglement. When two particles interact, their states become linked so completely that measuring one instantly determines the state of the other, no matter the distance between them. Einstein called it spooky action at a distance. But the deeper mystery isn't the distance, it's the timing. Entanglement doesn't care when the measurement happens. You could measure one particle now and the other later, and the results will correlate as though they were coordinated outside of time entirely. It's as if, at the quantum level, nature doesn't bother distinguishing now from then. This brings us to what many physicists quietly call the quantum rift, the invisible seam in reality where the classical and the quantum collide, where the flow of time fractures into a shimmering web of possibilities. It's not a rift in space, but in logic, a gap between what we observe and what the universe actually does when we're not watching. If retrocausality is real, if future events can influence the past, then time itself may be a feedback loop, not a line. And every particle in the universe could be participating in this grand conversation between what was, what is, and what will be. In that sense, time travel isn't a machine, it's a property of existence, a dialogue between the universe and itself. Think of memory for a moment. When you recall a past event, your brain reactivates the same neural networks that fired when that event first occurred. In a very real way, you are re-experiencing the past not as it was, but as it is now, filtered through the current moment. If consciousness itself operates through quantum processes and there's growing evidence, it might then, each act of remembrance could be a small act of time travel, a ripple of awareness echoing backward across the quantum rift. Maybe that's why we can learn from the past, because at some level, we're still connected to it. And maybe the choices we make, the dreams we pursue, the fears we overcome, all of it sends information not just forward to shape our future, but backward to reinforce the path that led us here. In that way, causality becomes not a straight arrow, but a circle of influence, looping endlessly between potential and realization. So, could time travel already be happening on a quantum scale? Perhaps it's not just happening. Perhaps it's fundamental. Perhaps every interaction, every entanglement, every act of observation is a microcosmic journey through time. A negotiation between what the universe could be and what it will allow itself to become. And maybe, just maybe, that's why we find ourselves here, conscious, reflective, aware, standing at the intersection of the infinite past and the infinite future, watching both shimmer in the fragile, beautiful illusion we call now. At some point in every great mystery, the detective realizes he's been part of the story all along. In physics, that moment came when we discovered that to observe the universe is not to stand outside it, it is to interfere with it. The quantum world taught us that reality doesn't merely exist for us to measure. Reality becomes definite through the very act of measurement. And that fact forces us to ask a question that science has long avoided. What exactly does it mean to observe? A detector doesn't think, a Geiger counter doesn't dream. Yet when it clicks, the universe seems to commit to one version of events. So is observation simply the registration of data, or is something deeper taking place, something that only consciousness can supply? The more we study it, the more that boundary blurs. At the smallest scales, measurement means interaction. One system touches another, information passes between them, and probabilities collapse into a single outcome. But in the human brain, observation is not just interaction, it's awareness. It's experience. And perhaps that experience is the missing ingredient, the bridge between quantum potential and tangible reality. Think of the famous Schrodinger's cat thought experiment. A cat sealed in a box linked to a quantum trigger that may or may not release poison depending on the decay of a single atom. Until someone opens the box, the cat is both alive and dead, a superposition of mutually exclusive states. But the moment an observer looks, the wave function collapses, and one reality becomes true. Now, what if the observer isn't a person, but the universe itself? After all, every particle interacts with every other. In that sense, reality has been observing itself since the dawn of time. We are simply the latest, most articulate expression of that self-observation. Some physicists describe this as participatory cosmology, QI. The universe, they say, is not a pre-written script, it's a dialogue. Each act of measurement is like a word in an ongoing conversation between matter and mind, between what could be and what is. John Archibald Wheeler, one of Einstein's last students, once phrased it perfectly. No phenomenon is a real phenomenon until it is an observed phenomenon. He called it the participatory universe. In that universe, observers are not passengers, they are co-authors. Which means that every time we measure, notice, remember, or imagine, we're helping to finalize reality's draft. Now picture consciousness as a field, an emergent property not of one brain, but of countless interactions echoing through time. If consciousness and quantum mechanics are entangled even loosely, then the act of awareness could send ripples across the temporal dimension itself. In that sense, thought becomes a form of time travel. Memory is our bridge to the past. Imagination, our bridge to the future. And both are powered by the same biological machinery, the same neurons firing patterns that loop through electrochemical time. The mind doesn't travel linearly, it leaps, revises, anticipates. Inside the skull, time is already nonlinear. Every scientist knows that the equations of quantum mechanics work both ways in time, but every human being feels the asymmetry of experience. We remember yesterday, but not tomorrow. We can imagine the future, but we cannot remember it. Why? Perhaps because consciousness is tuned, like a radio, to a narrow band of temporal frequencies, a band that happens to play forward. But that doesn't mean other bands aren't humming underneath. In rare experiments, when people make rapid intuitive decisions, their bodies sometimes react fractions of a second before the triggering event occurs. The data are subtle, controversial, but they hint that information might seep backward through the boundary of awareness. If even a trace of that is true, then the mind may already be surfing microcurrents of time that physics is only beginning to chart. Here's the paradox. If the observer helps define reality, and the observer exists within reality, then cause and effect chase each other in a circle. The universe produces consciousness. Consciousness finalizes the universe. Which came first? Maybe neither. Maybe they emerged together, like two sides of the same quantum coin, flipping endlessly in the void until awareness and matter recognized each other. That recognition is happening right now. Every thought you have is the cosmos noticing itself. Every question you ask about time is time asking about itself through you. Some worry that this line of thought veers into mysticism, but it need not. It's still physics, just physics extended to its logical conclusion. If reality is information and observation is the process by which information becomes definite, then consciousness is part of the physical story, not apart from it. The real question is, how deep does that connection go? Could a sufficiently coherent act of observation, collective, deliberate, informed, alter the statistical balance of outcomes? Could awareness, in aggregate, nudge probability itself? We don't yet know, but consider how small shifts of probability drive everything from genetic mutations to cosmic structure. If consciousness can shift the tiniest odds, then over billions of years, awareness could sculpt the very shape of the cosmos. Look up at the night sky. Every photon entering your eye left its star. Years, centuries, sometimes millennia ago. When you gaze at a galaxy 100 million light years distant, you are literally seeing into the past. But those photons complete their journey in you. The act of seeing completes the event that began before humans even existed. In that moment, observer and observed become one continuous process stretching across 100 million years of space and time. Observation is not passive, it is the closure of a cosmic circuit. Perhaps that's the real secret of the quantum world. Reality doesn't simply happen to us, it happens through us. We are the interface where probability meets perception, where possibility crystallizes into history. And if time travel is already happening on a quantum scale, then consciousness is both passenger and pilot, both witness and participant. The observer's paradox is not a problem to be solved, it's an invitation to be accepted, because it reminds us that our awareness isn't an accident within the cosmos. It's one of the ways the cosmos makes itself real. Somewhere deep in the basement of a physics lab, a detector clicks. To most of us, that sound is unremarkable, a tick in the silence. But to the physicist listening, that single click might mean that information from the future has just brushed against the present. It sounds impossible, yet it's a possibility the equations themselves refuse to dismiss. It began quietly in the late 20th century, when a handful of researchers revisited the strange family of delayed choice experiments. In these setups, the decision about how to measure a photon is made only after the photon should have already decided what to do. And still, the results line up as though that future decision had already been taken into account. It's not that anyone has sent a postcard back through time. It's subtler than that. The statistics of the experiment carry the unmistakable signature of information flowing both ways. The universe, it seems, keeps its options open until the last possible instant, and that instant can reach backward as well as forward. A few theorists, like John Cramer with his transactional interpretation, began to imagine the quantum world as a conversation between emitters and absorbers. When a particle is emitted, it sends a retarded wave forward in time, and its potential absorber sends an advanced wave backward. Reality is the handshake that occurs when both signals meet. The deal isn't struck until every condition, past and future, is satisfied. If that's true, then every photon you see from a star tonight didn't just begin its journey billions of years ago, it also completed that journey billions of years in the future when it found your eye. The past and future collaborate to produce the present event. In the macroscopic world, we rarely notice this handshake because thermal noise drowns it out. But at quantum scales, the ripples are visible. When experimentalists adjust detectors after a photon has already passed, the interference pattern shifts to match the new conditions, as if the photon went back and edited its own history. The math holds. What it means is less clear. Does the photon actually retrace its steps, rewriting the film reel of its path? Or is time itself less like a film and more like a self-consistent equation where all variables, past and future, must balance simultaneously? Either way, the implication is profound. The future is not empty. It's already leaning back toward us, shaping the probabilities we call the present. You might think such effects belong only to the realm of particle physics. But consider this. The brain is a quantum chemical network operating at the edge of chaos. Its microtubules, synapses, and ion channels all dance in the same quantum field as everything else. If information can, in principle, move backward across that field, then perhaps traces of the future whisper inside our neural noise. Most of us have felt moments that seem to precede themselves, a sudden certainty before the evidence arrives. A flash of intuition that later proves right. Science treats such experiences cautiously, as it should. Yet the possibility lingers that intuition might be biology's faint echo of retrocausal information. Our consciousness catching the shimmer of events not yet unfolded. Think of time not as a straight line, but as a feedback network. Every cause sends its effects forward, but every effect sends information backward to refine the cause. The system seeks self-consistency, like an equation solving for balance. You can't change the past without simultaneously changing the future, because both are solutions of the same cosmic formula. That's why paradoxes, those science fiction nightmares of killing your own grandfather, never manifest in real physics. If retrocausality exists, it's self-correcting. Only timelines that fit the total set of boundary conditions can persist. In that sense, the universe doesn't rewrite history. It edits it until the story makes sense. Modern labs are now testing these ideas with entangled photons spread across kilometers of fiber optic cable, with measurement choices delayed by random number generators, sometimes located in orbiting satellites. The results keep hinting that correlations form instantaneously, or perhaps atemporally outside the usual order of events. It's tempting to call this time travel, but what's really happening might be deeper. The universe isn't moving data through time at all. It's treating time as another coordinate in a single timeless computation. Everything that can happen is computed together, and we experience one consistent branch of that solution as history. If that's true, then echoes from the future surround us constantly. They just arrive coded in probabilities, too faint for us to decode directly. Every quantum fluctuation, every random choice could be part of the negotiation between what will be and what must have been. It doesn't mean destiny is fixed. It means the universe values coherence. Among the infinite ways events could unfold, only those that fit both past and future constraints survive. We live, therefore, in a cosmos that is not marching forward, but converging on self-consistency. And our actions right now are part of the data that the future must reconcile. When you choose kindness over cruelty, curiosity over fear, you're not just influencing tomorrow, you're shaping the range of tomorrows that can feed information back into today. In that light, ethics becomes physics. The structure of time rewards coherence, punishes contradiction. Civilization, too, is a feedback system seeking stability across generations. Perhaps that's why humanity keeps rediscovering the same moral truths, even after ages of forgetting. Maybe compassion, honesty, and courage endure because they're the behaviors that keep the timeline self-consistent. If the universe is whispering from the future, it does so not through prophecy, but through pattern. Each scientific breakthrough, each flash of insight, each sudden alignment of human ingenuity may be one of those whispers, the future drawing us toward itself. Einstein once said that the most incomprehensible thing about the universe is that it is comprehensible. Maybe comprehension itself is the echo, a resonance between minds now and the knowledge they will someday hold. So when we study the cosmos, we may be hearing both its ancient voice and its unborn one, calling to us across the same continuum. Imagine, just for a moment, that all of human history, every invention, every revolution, every act of love, was the universe adjusting itself to make sure that you, right now, could hear this thought. That the act of understanding time is itself the completion of a loop begun billions of years ago in a cloud of stardust. If that's true, then we are not small against the backdrop of time. We are the mechanism by which time becomes aware of itself. Every discovery we make, every choice we take, feeds back into the grand equation, tuning the cosmos toward coherence. We are, quite literally, the echo made flesh. We've traveled from the vast machinery of relativity to the trembling probabilities of quantum space, and found that the universe may already be exchanging whispers between past and future. But here, standing in ordinary daylight, what does any of that mean for us, people who wake to alarms, pay bills, worry, love, hope, and age? Because a theory, however elegant, finds its true meaning only when it passes through a human heart. Every morning, you step out the door. You experience entropy firsthand. Coffee cools. Cars rust. We grow older. Entropy gives time its arrow, and that arrow writes the story of our lives in one direction only. Yet memory lets us bend that arrow slightly backward, and imagination lets us bend it forward. You plan tomorrow, you replay yesterday. In those moments, you perform the same act the universe performs at the quantum level. You negotiate between what has been and what could be. Your brain does this through electric storms of probability. A thought is not a solid object. It's a wave collapsing into meaning. You are quite literally a quantum system scaled up and slowed down enough to call itself someone. Neurologists tell us that remembering is not like retrieving a file, it's like rewriting one. Each recollection slightly edits the original. In that sense, memory is the biological form of retrocausality. Every time you remember who you are, you adjust who you were. And when a society remembers its history through stories, monuments, or lessons, it too is editing its past to make a future that can hold together. The past is not fixed. It's continuously updated by what the present chooses to value. That's why education matters. That's why empathy matters. because how we remember will decide which versions of the future are even possible. Einstein taught us that mass curves space-time, but choice curves destiny. Each decision, no matter how small, nudges the trajectory of countless outcomes, just as gravity bends light. When you decide to act with kindness rather than indifference, that moment doesn't vanish. It ripples forward into the lives of others, and if the quantum feedback picture is even half right, some echo of that choice ripples backward too, stabilizing the path that led you there. The universe, it seems, favors coherence at every level, from atoms aligning spins to people aligning purpose. We often think of responsibility as a burden. But if every action resonates through the lattice of time, then responsibility is simply awareness of connection. You are entangled not just with the people you know, but with generations you will never meet. A scientist in a lab adjusting a lens may be aligning photons that will one day guide spacecraft to another star. A teacher explaining fractions to a restless child might be tuning the mind that will solve an energy crisis a century hence. Cause and effect do not respect our calendar. They belong to the network of time itself. Meaning feels abstract, but perhaps it's measurable, an emergent property of coherence across scales. A life rich in meaning is one whose actions, memories, and hopes are aligned across time. Noise minimized, signal strengthened. When you create art, when you forgive, when you learn, you're reducing entropy locally. You're creating structure where there was randomness, order where there was drift. That's not poetry. It's thermodynamics applied to consciousness. We can't halt the universe's overall drift toward disorder, but we can carve small islands of order homes, friendships, discoveries that momentarily push back the tide. That push is what we call purpose. If retrocausality knits the cosmos into a single feedback loop, then every life is a thread woven through that same tapestry. When we harm each other, the pattern phrase, when we cooperate, the design sharpens. This isn't moralism, it's physics wearing a human face. Systems that fight coherence collapse. Systems that harmonize endure. Perhaps civilizations rise and fall according to how well they synchronize the local arrows of time, aligning individual hopes with collective survival. In that sense, ethics is entropy management. Compassion is the low energy state of a stable society. Hope is not naive optimism, it's a form of time engineering. To hope is to reach forward, gather possibilities that do not yet exist, and pull them toward reality. Every invention, every reform, every work of art began as that kind of temporal experiment, a mind entangling itself with a future worth living in. When hope dies, time flattens. When hope thrives, new dimensions open. And maybe that's the deepest reason consciousness evolved, to keep the universe experimenting with itself. No machine whirs in the background, no wormhole glows, but we are already time travelers. Every thought traverses years of memory. Every act alters centuries yet unborn. Each breath you take contains atoms exhaled by ancient forests and future children alike. You move through a medium far larger than the seconds on your watch. To recognize that is not arrogance, it's gratitude. You are participating in a cosmic feedback loop billions of years in the making. And for a brief window called a lifetime, you get to steer your small part of it. So, what should we do with this knowledge that time may bend, that consciousness may matter, that the future might already be listening? Perhaps the answer is beautifully simple. Live as though every act reverberates forever, because in some form, it does. Speak as though your words might echo backward, healing something you can no longer see. Build as though your descendants are watching, because in a quantum sense, they already are. We began with a question about time. We end with a question about ourselves. For centuries, humanity has looked upward, chasing the horizon of knowledge. From the first spark that lifted a rocket skyward to the silent images beamed from the edge of the solar system. Each step outward was also a step inward into the nature of awareness, the architecture of meaning, the strange partnership between mind and cosmos. Because the deeper we peer into the universe, the more clearly we see that the universe is peering back. Space and time are the 4 dimensions we inhabit. But there may be a 5th one, not measured in meters or seconds, but in awareness, a dimension that connects events through understanding, intention, and memory. We live within it. Whenever we reflect, empathize, or imagine, it's the bridge that turns existence into experience. Perhaps this 5th dimension is what the cosmos has been building toward since the first hydrogen atom learned to shine. The emergence of self-aware matter, capable of contemplating its own timeline. When astronauts looked down at Earth and saw a single fragile blue marble, something changed in us. Borders faded, rivalries shrank. For a heartbeat, 7 billion stories shared one view. That was the 5th dimension awareness extending across space, uniting a planet in one frame of consciousness. The space race was never just about reaching the moon. It was about proving that curiosity can overcome gravity. Now, the new frontier is not distance, but understanding, quantum communication, artificial intelligence, neural interfaces, all of them are ways the universe is learning to think in larger patterns. We are its neurons, firing across centuries, connecting what was once isolated into a single global mind. Our task is to make that mind wise. Because knowledge without wisdom is acceleration without direction and time, as we've learned, doesn't forgive confusion. If the future can echo into the present, then responsibility is not just for what we cause, but for what we permit. Every act of cruelty adds noise to the timeline. Every act of compassion restores coherence. We are engineers of temporal harmony, adjusting the tension between what has been and what can be. When we teach, create, and protect, we're sending stable signals into the future. When we despair, exploit, or destroy, we scatter interference across our own history. In the quantum fabric of cause and effect, morality and physics may be closer than we think. Maybe the universe's final trick is simple. It evolves intelligence, not merely to survive, but to understand. Awareness is how the cosmos ensures that time does not waste itself. Through us, the universe remembers, corrects, aspires. We are its conscience written in carbon, its curiosity given voice. And if time travel already happens at the quantum level, then every choice we make, each moment of kindness, each discovery, each brave idea radiates both forward and backward, refining the path that brought us here. The future is not waiting, it's responding. Picture the first human who ever looked at the stars with wonder and asked, why? Now picture the last human who will ever do the same. Between them stretches the full arc of our species, an unbroken chain of minds reflecting on the same cosmic mystery. That continuity is time travel, knowledge handed forward, meaning handed back. So when you look up tonight, know this: the light reaching you left its star long before humanity existed, but it completes its journey only when it meets your gaze. In that instant, past and future touch, and the universe becomes whole. The 5th dimension is not a place. It's a realization that we are not observers of time, but participants in its design. That our awareness is the final variable in the cosmic equation. And that every breath, every thought, every act of understanding is the universe learning, at last, to know itself. So here we are, creatures made of dust and memory, standing between the atoms and the stars. We have measured time, bent it, argued about it, but the truest discovery is simpler. Time was never something outside of us. It was the rhythm by which the universe learned to speak in first person. Every civilization, every heart beats inside that rhythm. And when our brief spark fades, the pattern remains, encoded in the photons we've launched, the data we've shared, the kindness we've left behind. Someday another mind will find those traces, and for a moment, past and future will recognize each other again. That recognition, fleeting, infinite, is what we call awareness. It's what makes the cosmos more than matter. It's what makes it alive. So breathe, look up. You are not merely passing through time. You are shaping it. One thought, one action, one luminous second at a time. And in that single eternal moment, the universe finally knows what it means to exist.